our graphs. Exponential growth is unrestricted. An exponential growth function increases at an ever-increasing rate and is not bounded above. That's pretty much what we talked about yesterday, right? Exponential growth will just keep growing exponentially. In logistic growth, you got to think about it like this. If you think about a pond with fish in it, how many people know someone or have a pond with fish in it by their house? Oh, right? Okay. Now, you think about it, are the number of fish going to keep growing exponentially? No, what's eventually going to happen? They're going to die off, right? Because there's not enough food, not enough water, not enough oxygen, right? So what's going to happen is that fish population, there's going to be a maximum sustainable population in that pond. That's the whole idea between logistic growth, okay? So here's the definition for logistic growth. Let A, B, C, and K be positive constants and B less than 1. A logistic growth function in X that can be written in the form f of x equals c over 1 plus a times b to the x, or c over 1 plus a times e to the negative kx. Because remember, our exponential function yesterday here could be written in the form a times e to the negative kx. We talked about that yesterday. Now the constant c is going to be the limit to growth. The c value is going to be the highest that your population can ever be. Okay? It's also going to be a horizontal asymptote. So in this function, you're going to have a horizontal asymptote at y equals 0 and at y equals c, that top value. Okay? Now we have a disclaimer here. We're only going to talk about logistic growth functions. We're not going to talk about logistic decay functions. Okay? So let's look at this. What is the domain of the logistic function? Well, if we graph that, I just want you to graph this on your calculator. 1 divided by 1 plus e to the negative x. Now, a window that I would suggest using, I would go negative 10 to 10 is fine, but I go negative 1 to 2 would be fine. Okay, there's second ln is e. Now, if you look at this here, what is the domain of this function? What does it look like the domain of this function should be? The domain is going to be negative infinity to infinity, all real numbers. Now, if we look at the graph here, what does it look like the range is going to be? It's going to be 0 to 1 is going to be our range. Is this graph continuous? Yeah. Do you have to pick up your pencil to draw this graph? No. So this graph would be continuous. Okay. It's always increasing. What about symmetry? What about symmetry? So if you reflected this way, okay, so it's not going to be over the y-axis, it's not over the origin, so it's not either even or odd. But Drew, I think you're onto something, right?
It's like if you like.
What point is that, Drew? It'd be 0 and 1/2. So this is symmetric about the point 0, 1/2. I know you do.
It's okay, Drew.
Everybody has mistakes.
Okay. So there is no even odd symmetry, but it is symmetric about the point 0, 1/2. Now, if we look at our boundedness, is it bounded above, bounded below, both, or neither? It is bounded by both. So this would be considered a bounded graph. And remember, our boundedness goes with our range. There's a lower part of our range at 0. There's an upper part of our range at 1. So that's why it's bounded. Are there any mins and maxes? Remember, mins and maxes on the extrema occur when it switches from increasing to decreasing or decreasing to increasing. This function is always increasing, so there is no mins or maxes. And then asymptotes. We kind of already talked about this. Y equals 0 will be an asymptote, and then y equals 1 will be an asymptote. And that makes sense why y equals 1 is an asymptote, because we said y equals c before was an asymptote. Now, as x approaches negative infinity, what's y approaching? Y is approaching 0. As x approaches positive infinity, y approaches 1. All right. Now, in the next example, we're actually going to talk about some of this stuff. Look at example 6. Okay, I graphed it here. I'm going to give you the points and everything like that. So why don't you put that into your grapher first for 3.1. So into our calculator, we're going to put this. 8 divided by 1 plus. So there's the equation you want to put in your calculator. The window that I would use negative 10 to 20. And negative 2 to 10. Okay, that's the window that I would use. So we need to graph this. Okay, now, a couple of things that we notice. Here's one horizontal asymptote. Here's another horizontal asymptote, because we need to find the y-intercepts and the horizontal asymptotes. Horizontal asymptote will be y equals 0 as one of them. The other one will be y equals 8. 8 is the number in the numerator, so y equals 8 will be our other horizontal asymptote. Okay? Now, to find our y-intercept, that is when x is equal to 0, so we're going to put 0 in for x to find our y-intercept. So 8 over 1 plus 3 times 0.7 to the 0 power. Now we talked about yesterday, anything to the 0 power is how much? Anything to the 0 power is 1. So 8 over 1 plus 3, which is 8 divided by 4, and that's going to be 2. So our y-intercept will be 0, 2. So therefore, we found all of our horizontal asymptotes. We found our y-intercept. Okay? Any questions right this second? Now, let's look at B. Again, let's graph B. 20 divided by 1 plus 2 e to the negative 3x. Now the window that I would use here is negative 2 to 4 and negative 5 to 25. You graph that, you get something that looks like this. All right. Now, again, horizontal asymptotes. Horizontal asymptote. First one is going to be y equals 0. What's my second one going to be? Y equals 20. My y-intercept, again, is where x is equal to 0. Where have this here. E to the 0 power would be 1, so really we're going to have 20 over 3, or 6 2/3. So my y-intercept will be 0 and 6 2/3. Now we can check that on our graph. If we let x equal 0, you will get 6.666666666666667. All right, which is 6 2/3. Okay, so that does tell you your y-intercept is. Yeah. How do I get 3? Well, e to the 0 power is 1, right? So I have 1 plus 2 times 1. 1 plus 2 is 3, so that's how I get 3. Got it? Okay. What I want you guys to do, once you guys work on C, you are going to have to change your window. I would change it back to what we had first. So I would do that for C. Actually, do you even need a graph for C? Or can you do this all algebraically? Try doing it algebraically. Okay, now when we do this, our horizontal asymptotes be y equals 0 and y equals what? 12. Y-intercept will be where x is 0. So it'll be 12 over 3, 4, 4. So your y-intercept will be at 0, 4. Now, are there any questions on example 6?
Why do you have to grab it?
Just so you can see what it looks like. That's the only reason you graph it.